Hi everyone, this is a video from Math OD2. This is solving systems of linear equations using substitution, and in the current textbook, this is section 2.2. So a lot of my students like me to break problems down into steps, okay? So if we want to use substitution, okay, and I'll just give you guys a preview of coming attractions here. Substitution is not the best method to solve this particular system of equations. Elimination would be much faster and easier, but I wanted to pick a really challenging and difficult problem for my video to really cover all the bases to help everybody increase their understanding and answer your questions. So, if we had to use substitution, if somebody just made us use that method to solve the system of equations, okay, the very first thing you have to do, if it's not already done for you, is that you have to isolate one variable, okay, and it can be either x or y, okay, but we're going to have to solve for one or the other. So what I always do, because why do work that you don't have to do, right, is I go through here and try to find what variable is already very close to being by itself. In other words, are there any variables here which already have a coefficient of 1? So if you look closely, you might notice that this y here, do you guys see? The y already has a coefficient of 1. So to save myself time and energy, I am going to choose to rearrange this second equation here by adding 2x to both sides of the equation, which yields y equals 5 plus 2x, or if you'd like, you could write y equals 2x plus 5. So that's my first step, and again, I chose this equation intentionally because it would have the fewest number of steps to have me reach my goal, which was isolating my variable. Okay, so I've isolated y. My second step, anytime I'm using substitution, is to do exactly what the name suggests, which is to substitute, I don't know why I put an S there, substitute the isolated variable. In this case, our isolated variable is y, into the other equation. So my other equation, as you can see, is the equation 6x minus 3y equals negative 9. So I'll try to use some colors here. So we found that y is equal to 5 plus 2x. So that means wherever I see y in this other equation, I'm not going to write y anymore. Instead of writing y, I'm going to write 5 plus 2x. Okay, so take a minute, look at what I did, make sure that it makes sense to you. Okay, so from here, right, we have an equation in one variable. Now, it's a little bit messy, we have to do some cleanup, but relative to what we had before, where we had two variables, this is something we would have seen maybe back in Algebra 1, and we can proceed with simplifying and solving. Okay, so you might notice over here that we have, it looks like a positive 6x and a negative 6x. So we have some like terms which we can combine. 6x minus 6x is 0. So we end up with negative 15 is equal to negative 9. Uh-oh. Well, that statement, you probably realize, is false. That is not something that is true. But that's okay, because if you watch my very first video on chapter 2, you'll remember that can happen sometimes. In fact, anytime I have two lines that are parallel, they never meet. They do not intersect. So there is no solution. Okay, so it doesn't mean that we did anything wrong at all. It simply means that this system of linear equations does not have a solution.